Hey guys, welcome back. So I'm going to get back on this LeBlond lathe cross feed nut, and what we're going to do right now, I'm going to show you how I measured this thing out. I went ahead yesterday, I did some preliminary measuring to go ahead and get all my dimensions that I need to know. I wanted to go ahead and get that out of the way, and I got everything wrote down so that I would know what I needed to do to machine this. And today I wanted to just kind of go over and show you the things that I use to measure this out, you know, with my different measuring tools that I have here at my disposal. So we've got our Brown and Sharp height gauge. You got a Brown and Sharp height gauge here with an indicator on it, and over here we've got a couple of pin gauges right here, a micrometer. This is my Starrett groove mic, we use that, and we got our Starrett number 221, and I was using this to verify these pin gauges right here. Now these are some pin gauges that were given to me by a viewer. I don't recall who that was now. It was last year, and I remember whenever I opened the box that this case was in, the case had opened up and most all these pin gauges fell out. They were all mixed up in the box, but they all got little dings on them all over them from bouncing around in that box. These are those cheap import made in China pin gauges, and I'm sure they're good. They're soft. So if they get abused like they were whenever they were sent here in that box, you know, you're going to get little dings on them, and they're not going to fit in the hole that you're trying to measure. So I had to take a stone and just lightly stone the edges down here near the corners, and then all these little dings on here to be able to use them. So I used the 221 mic right here to verify that they were on size, and I still think that this mic is off maybe 1/10. I need to get that checked out, but the pin gauges were measuring, one was measuring like 2/10 under, and then the other one was like 3/10 under. That's probably in the spec that they give you whenever you buy those. But I'll show you what we were using the pin gauges for, and I went ahead and mic'd the total thickness of this. So here's your break right there, but with this being cast, it's like a really nice puzzle piece. It falls right back into place right there. So that should be within 1 to 2 thousandths of the you know, the right distance that everything is at. So I mic'd this, and then I started getting some measurements here on this face. You got a little raised area. I got that painted green. That's your little raised area. So I've got some measurements here, and I want to show you how I got those using these tools over here. So the first thing I wanted to do was measure the bore, and I thought, since we've got that set of pin gauges that was in range, that we would use those. So we'll start with this piece here, the piece that's broke off, and here's an 815 pin gauge. All right, we got it to go in there. So I believe what we have is a little bit of wear in this thing. Let's see. I believe this end here in your threads is going to have about 2 thousandths of wear over this end right there. So we got that pin gauge, and then we also have this one right here, which this one is an 813 pin gauge. And it's a very close fit. It's kind of hard to get it started in there. There we go. All right, so we got our pin gauge, and it's got a couple spots where it kind of tightens up. So I'm calling that an 813 bore, which is going to be 13/16 on your imperial sizes. So we got it wrote down. We're gonna shoot for 813, and with a tolerance hopefully of about 1 thousandths. Okay, so there's our bores. All right, on this end right here, we have an oil groove in there. Let's see if I can get it in there a little tighter. We have an oil groove right there, and you do have the spiral grooves that goes down through there as well. You can kind of see that. I believe you'll be able to see that there. Now there's not a there's not an internal groove on this end of it. They just spiral down and come off. I'm sorry, they stop on this one. But this end actually has a radius groove machined in there. Alright, so I've already taken my measurements and I'll show you what we got right there. So our groove diameter is 1/8 wide, and I used my groove mics to get that measurement right there. Distance from the end is 468. That's to the center. So it's from this edge to the center of that groove is 468. Also 15-30 seconds if you're worried about that, what that is in fraction. The diameter of that through hole is 3/16. And then our groove diameter, which I used these are little stair inside spring calipers here, and use that in, and we put those in there like so until they feel right, and then just measure those. You can measure them with some regular dial calipers. So just a rough measurement. That's not really critical there. So I wrote it down as 942. I'm sure that was originally, on the print, that was probably 15/16. So there's our dimensions right there for getting that groove machined on this end. Now we've got some measurements for the flange end right here. We've got our flange diameter, 3" 488. That's this diameter right here. And we're gonna, let's see, what I'm gonna do is go ahead and put a groove on this end just like this other end right there. So we're gonna have one of these grooves, and that's what I wrote down right there. The groove distance from end, we're gonna make it a 1/4 inch from the end. Again, I use the Starrett groove mics right here to reach in there and kind of measure where this original groove stops, and we got about a 1/4 inch. And then we're going to make it the same groove width, diameter, that kind of stuff. All right, I got some more dimensions there. Let's see what else we got. So the total length for this, I mic'd it using the 3 to 4 inch mic, and I mic'd. Let's get this back together now. From this face here, which I kind of lapped that off, I honed it, make sure there was no burrs, and then I mic'd it to this right here. And what I was getting was 3.691. That's our dimension. So that's going to be 3 11/16 is your nominal size right there. Okay. Now I set this up using a height gauge. I brought our height gauge over, and I came over and started checking this with an indicator to see what our rise and fall was. And I found that this green, where this green Sharpie mark is, that's that raised lip, is higher by 0.02 of an inch. Okay. So our total distance, our total height to this edge right here is going to be 3" 693. You follow me? All right, so I'm going to show you what I got set up here and what I was doing to measure. So we've got our part setting on the granite table there, and I started off with the Brian Sharp height gauge. I wanted to go ahead and measure what the total height was there. So this green lip, I just highlighted it with a Sharpie there. So that's the highest point, and I got the height gauge where it's just touching it. I don't know if you can hear that, but it's just touching it, and I can feel the friction there. So I've already verified on the scale right here. I know you're not going to be able to see that, but I've already verified it, and I've got the dimension wrote down right there using the height gauge, 3.693. So that's going to be our total width there. So now we come in here with our indicator, and I've already got this set, by the way. So our highest lip right there, we've got it set at 0. when you come in here to this undercut, it's going to drop off 22 thousandths, and then we'll come all the way in to the center hub area, which is what I was originally assuming the total width where it would be measured. But if you see the indicator right there, let me make sure that glare ain't bothering you. That's showing just a smidge over 2 thousandths, but I'm calling that 2 thousandths. So this inner hub is 2 thousandths lower than this. Now I can only assume that LeBlond machined it that way. I don't know if it's supposed to be machined that way or if it's worn in that way or what, but I'm going to try to duplicate this part as close to this piece as I can. So we're just going to make it the same. So we'll drop this face down 2 thousandths. We'll drop that undercut area, 22 thousandths. All right, we're going to come back up to our 0 point, and then this outer area here drops down as well 10 thousandths. So that's where I got it all wrote down right there, the 10 thousandths. So that's a pretty convenient way to measure all of those different heights right there and see where we're at. It's a little bit easier doing it that way, especially since this is a cast piece. So you really have no good way of measuring, from the back right there what the thickness is, because it's not consistent. It's just a casting. All right, so I wanted to share that with you, and it's fun to be able to set up our tools and be able to take measurements like this, using our height gauges and our indicators. So we've got all of our measurements jotted down. So now it's time to go back to the Monarch and let's start finishing this piece out. I'm going to go ahead and start getting a hole drilled down through there. And I was going to point out that what I'm going to do is drill it close to size. I'm going to bore it close to size, but I'm going to leave it a little bit small. And we'll finish out that groove that I need to put on this side. And after that, I'm going to flip it around and go ahead and finish out all the machine work on this other side. And then once I do, I'll bore it so that bore is completely true with that face. I want to make sure that it is true because of the dial that's going to be spinning on that side right there. It'll be very close. I mean, it should be within 1 or 2 thousandths of being completely concentric, I would hope. Trying to take the drilling a little easier than normal and try to eliminate that drill from trying to push off center line there. Typically happens whenever you start running a drill all the way through a bore. That center chisel point starts running off center a little bit, and this tailstock is not perfectly in line true with the axis of the machine, which is another fix that I would like to work on one of these days. Do some measuring and work on this tailstock and make sure we've got it nice and parallel and level with the axis of the spindle there. Using a brand new drill bit. Still got a factory grind on it. I used that on purpose because I knew I had a good drill there that I was going to be using. Once it starts binding up a little bit, we can back it out. Take a brush and brush some chips off. We're getting really close to being through there. Alright, if you look at that drill, you can see that it's just barely wiggling around. Very little at all. So we did good on our hole. It's not good to let your tools dwell, but I was doing that to try to make a point there and show you. So up next, we're going to go in with a 25-30 seconds taper sink drill. That should drill it. Nominal size for that is going to be like 781. So we're going to poke it in there just a bit and use our calipers to verify and make sure that it's drilling. I don't want it to drill it oversized very much because that's only going to give us about 30 thousandths to bore out of there. Let me see. I think I might have to slow it down. Let's see what it does. So it's cutting about 10 thousandths big. I think we can live with that. I'll just point out real quick, it's one of those cases, see, I'm using my earplugs because of that loud squeaking sound. That stuff will screw your ears up. Okay, I think we got us a successful hole down through there. About 791, 792, so that should clean up. That's going to give us about 20 thousandths to clean up right there. I'm going to use this piece of 3/16 high-speed steel tool bit, and we're going to make a radius tool to cut the oil groove. That's fitting pretty close right there. I'll just take that and hone that in. I think that'll work. It's not nothing that has to be super critical, it's just an oil groove. So 126, I mean, I'm gonna call it there. So go over to the stone and just kind of hone it, and then we'll cut it off so that it'll fit inside the bore. That's helping me get it shaped in on the proper radius. I got my gauge right here that I can use to check it with. I need to look at it real quick. Yeah, I got to hit the corners just a little bit more, but I mean, it's good the way it is right there. I am going to have to go back over to the grinder and probably give it just a little bit more relief down here on the bottom. We're gonna use this for cutting the grooves on the end, but we're also going to use it to cut our lengthway grooves as well, the ones that's going to connect end to end. I decided to go to the medium stone because it cuts a lot easier on this one. I needed to get a little bit more out of the corners to get the radius shaped. And as I said a minute ago, it's not that it's that critical, but you know, this is a tool that I can use later, so I might as well just go ahead and shape it the way that I want to for a 1/16 radius. So I'm just putting a little bit extra effort in there, and then I'll have it for another job, because I done spent 10 minutes looking through the drawers trying to find a good tool, and I couldn't find one. I found a couple that I would have had to regrind, but they were already really short. That's looking pretty good. Try my gauge again and see. Oh yeah, man, that's nearly perfect right there. I know you can't see it with the GoPro, but I'm looking at my light back there on the wall, and that thing is fitting that gauge just awesome right there. So we'll go back to our fine stone right here and hit it a few times just to kind of help smooth up that cutting edge. So I just mark it in the bar. I stick it in there. We're going to use this, I think it's a Williams boring bar right here. Yeah, it's a Williams. I stick it in there and kind of measure it, make sure it's going to clear the bore, and then just mark it. I'll cut it right behind that mark. And we got a good piece for later. And then there's our tool. We'll go dress up those sharp edges, and I think we'll be ready. This is a pretty hard shot to give you, but I'm going to try to get you what I can. So just to remind you, there's the groove that we're going to be cutting, right, that lines up with this hole here. So I've already calculated everything. This diameter is smaller than what we're going to finish at, so I've got that calculated. Once I touch off, we're going to go like 150 thousandths deep, and I've already got the center of the tool centered up on the very end of the part using the mag base indicator, this guy right there. So it's in the middle of the tool bit. I already offset it 1/16 of an inch. So our distance from the end is 468. Got the tool, I got the bar clearance so it ain't gonna rub there. 1, 2, 3, 4. 65. All right, there's 468 right there. So I'm going to go ahead and I'm going to re-zero this. So if I want to go back in there, I can go right back to the same spot. Okay, we're going to go ahead and all right, so there's our tool touching. You can tell the drill is off a little bit. Zero in the cross slide, and I got it wrote down here 150 thousandths, 151 if you want to get technical. There's 50. There's 100. Make sure I got room here. I think we're just gonna make it. Yeah, there we go. All right, so we'll back out. See how we did. It looks good to me. Let me move the camera, I'll get you a shot. It looks nice and shiny. Alright, maybe you can see that. So that's our 1/8 wide oil groove. So it should be the proper depth once we come in here and we bore this to size. Alright guys, I was planning on this being just a 2-part series, but we're going to make it a 3-part series. I apologize for that. I know you want to see this completed, but I've had a lot of stuff going on around here, you know, with the construction project, and I've just had a lot of things keeping me away from the shop right now. And I've been working on this a little bit at the time as I can, so I plan to get back out here over the weekend some and next week, and we'll get this project finished out, and we'll have a final video to finish it out next week. Okay.